We are
Movement STEM.
and I am Monse.
I'm Cos. And I'm Sol.
Today, we're going to talk about energy, being more specific about kinetic energy. But first, we're going to explain you the four interactions of energy. Number 1.
A strong nuclear, a force which can hold a nucleus together against the enormous forces of repulsion. For example, every atom is composed of quarks and gluons. The strong force binds these quarks together in groups to make subatomic particles, such as protons and neutrons. Thanks to these, gluons can be exchanged.
Number 2. Weak nuclear force. While the other forces hold things together, the weak force plays a great role in things falling apart or decaying. It is important to mention that this force is only effective at very short distance. Let's make it simpler. The weak force is responsible for much of the natural radiation. Think about a star or the sun. The process consists in a neutron in the nucleus changing into a proton and expelling an electron.
Number 3. Gravitational is a force between two masses. It always tries to pull two masses together. We've heard about it in Newton's universal law of gravitation. Do you remember the apple that fell from the tree? That's gravity. And just like the apple, we are attracted to the center of the earth thanks to this force. But even though all the matter of the universe is related to this force, gravitational force is the weakest force.
Number 4.
Electromagnetism is the forces between charges and the magnetic force. As the name says, in the electromagnetism, the electrons interact with other electrons to form electron bonds. To explain it better, let's think about magnets. If we have two with the same charge, the magnets will repel each other, whereas that if we have two different charges, they will attack themselves. We already have explained the four interactions of energy. Now, let's move on.
As we all know, among the universe there are different types of energy, but as we mentioned at the beginning, we're going to talk on a specific one, kinetic energy.
We asked some people what did they know about this energy. Let's see what they said. What do you know about the kinetic energy?
I know that is the energy of the movement.
Okay, thank you.
What do you know about kinetic energy?
Well, I know about kinetic energy, that is when an object has movement.
Even though, if they didn't know much about it, they both agree that kinetic energy is the energy of the motion. In other words, kinetic energy is the energy an object has in order to be able to move. It depends on two factors, mass and speed. This force is indispensable when we want to accelerate a body because in order to accelerate it, we must apply a force. Applying a force requires us to do work. After work has been done, energy has been transferred to the body. Now the body will be moving. The energy transfer is known as a kinetic energy.
There are two types of energy, transitional and rotational.
Transitional kinetic energy depends on the motion through space. For example, every single sport that uses a ball. Being more specific, a tennis player hitting the tennis ball with her racket. The ball contains the kinetic energy contained from the player hitting the ball. Rotational kinetic energy depends on an object's motion that is centered on an axis. Earth's rotation is an excellent example for this. Finally, if you want to calculate the kinetic energy, you must use the following formula. You must multiply half by the mass and the speed squared. You will obtain a joule.
To explain and describe everyday examples, we interview a couple of classmates who are on the robotic team of the campus first.
Hi Memo, hi Ivan. I would like to know how to use the kinetic energy, especially now that you are on a robotic team. How do you apply it in there?
Well, we don't precisely use kinetic energy, but we use chemical energy from batteries and use it in motors so we can have kinetic energy and make our robot move.
But not only make the robot move, but this chemical energy inside the batteries can be turned into kinetic energy with the motors that we use not only to move, but to throw the balls and to make the robot work.
Thank you so much.
As we said before, we can find kinetic energy in everything. If we are walking, running, or biking, we will find kinetic energy. The earth itself uses kinetic energy. Roller coasters work thanks to kinetic energy. Finally, let us tell you 9 fun facts of kinetic energy.
Number 9.
Kinetic energy can also be called transferred energy.
Number 8. Kinetic energy depends on the velocity of the object squared. This means that when the velocity of an object doubles, its kinetic energy quadruples. A car traveling at 60 miles per hour has 4 times the kinetic energy of an identical car traveling at 30 miles per hour, and hence the potential for 4 times more death and destruction in the event of a crash. Number 7.
Kinetic energy must always be either zero or a positive value. While velocity can have a positive or negative value, velocity squared is always positive.
Number 6.
Kinetic energy is not a vector, so a tennis ball thrown to the right with a velocity of 5 meters per second has the exact same kinetic energy as a tennis ball thrown down with a velocity of 5 meters per second.
Number 5.
The word kinetic comes from the ancient Greek word kinesis, which translates to motion.
Number 4. Although the concept of kinetic energy dates back to the days of Aristotle, Lord Kelvin is given the credit for first using the term around the year 1849. Number 3.
Kinetic energy is a scalar quantity, which means its quantities only have magnitude and there is no direction.
Number 2.
There are many different forms of energy, which include thermal, chemical, electrical, solar, nuclear, etc. The various types can be divided into 2 main groups: potential energy and guess which one is the other. Yes, kinetic energy.
Number 1. Any object that is pulled in an uphill manner, such as a roller coaster car, will gain potential kinetic energy. But pay closer attention. Once it hits the top, it has the most potential kinetic energy. Then it begins to move down the other side of the roller coaster and gains speed as well as kinetic energy. The funny thing is that going down, it is both gaining and losing potential kinetic energy, as it had already achieved the most when it was at the top. By the time the roller coaster car reaches the bottom, it has achieved the most of its kinetic energy and also is at the point on the least potential energy.